this is the last section of the chapter, all right? And so after this, we're done chapter 6, and that's why I'm kind of scared right now that you guys don't know this stuff. But anyways, we're going to put all this stuff together now, and this is what chapter 6 is going to be all about. I'm going to ask you now to solve what I call rational equations. Now, solving equations like this involves everything you've learned so far in this chapter. Remember the NPV stuff? Adding, subtracting, multiplying, dividing, all that stuff's coming back. For all rational equations, the first thing we ask you to do is always determine the, and I just told you, the NPVs, right? Or non-permissible values. That's what you need to do first. Then you might be thinking, Mr. Lee, I didn't really understand why we did all those things. You'll find out today, okay? And then afterwards, you just want to simplify the expressions by making sure each fraction has the same denominator, okay? And then, of course, once you've got the same denominators, we're going to make the numerators the same, and hopefully we'll be able to solve and get the answers, okay? So think about how you did fractions. We'll use that again. Think about how we added and subtracted fractions last day. We're going to use that again. Let's take a look at example number 1. 1A. Somebody help me out. What's the NPV for this question? Yeah, notice you're looking at the denominator, and in this case there's only one variable. It's x, and of course x can't be 0. Okay, write that down. Okay, now let me show you how we can actually add and subtract these equations to help us solve. Can someone tell me, oh yes or no, you don't have one? Sorry. Can someone tell me what's the common denominator out of all 3 of those fractions?
3x.
3 and an x. Good. So just like last day, what I'd like us to do first of all is rewrite every single one of these fractions with a denominator of 3x. Okay, this is just like last day. So from last day I said let's go ahead and find the common denominator, and my question to you is what factor am I missing from the fraction on the left? I had a 3, now I have a 3x. What am I missing? X, good. So I'm going to multiply the top by x. For the middle fraction here, we had a 4 on the top. What factor am I missing if I compare x with 3x? 3, good. So I'm going to multiply by 3. And then last but not least, the fraction on the right-hand side, I had a 3, and now I'm looking at 3x. So what am I missing? X, good. Don't be afraid to answer. We're here to learn. Okay. So the idea now is once you've made all the denominators the same, well, that just means that the numerators should be the same. So after this step, what I suggest you do is let's not worry about the denominators anymore. So I'll say something like this. Since the denominator is the same, okay, since the denominators are all the same, now we want to just make the numerators to be the same, okay? Make numerators the same. And so what I'm saying to you now is, hey, we can actually kind of ignore the denominator, and let's just worry about the numerator. Okay? And if you think about the numerator, I think we have to do some multiplication. X times x is x squared. X times minus 1 is minus x. Okay. 4 times 3 is 12. And x times x is x squared. Okay, now once again, notice all I've done now is ignore the denominator, and I've distributed the stuff in the numerator. And now this looks like a lovely question that we've done before. Can someone help me simplify this? Notice I've got an x squared on the left and an x squared on the right, so they just kind of disappear. And I guess what I have now is negative x plus 12 equals to 0. Can someone help me solve for x? Sure, I'll minus 12 on both sides. But then I want positive x, not negative x. So just divide by negative 1. I get x equals to positive 12. Okay. Double check. Make sure that x is not an NPV, because you can't have a solution that's equal to the non-permissible value. And it's not. So it looks okay. We're done.
You don't put it over the fractions?
Okay. What if it is? We'll talk about that in a second. Okay. So Kevin's question is, what happens if, in the end, I get an x that actually equals to NPV? We'll take a look at that later. Okay. Okay.
So if on the opposite sides of the equal sign, if they're both the same, then you just cross them out?
Yeah, because right here I just divided both sides by -1, right?
Yeah.
So I just get positives. Okay, ladies and gentlemen, let's try B. B is very similar to A. Help me out. NPVs, somebody? 0. Good. X can't be 0. Good. Look at the denominators and tell me what's the common denominator.
3x.
3x. Go for it then. Let me ask you to rewrite every single term with the denominator of 3x. Okay. Go for it. Go for it, go for it, go for it. Think about what's missing on the top. X, multiply that by x, I believe. The 2, I'm going to multiply by the 3. And then we've got the 1, and multiplying that by the x. Okay? So once again, you're looking at doing the same thing like last day, right? Adding, subtracting fractions, find the common denominator, find the equivalent fractions with that same denominator. And now the extra part is just equate the numerators. And I'll just quickly write a note here. You don't need to write a note in your notes, but I'm just doing it here because I want you to have some sort of English here so you know what you're doing. And I'll have x times x is x squared, 2 times 3 is 6, 1 times x is x. And now the question is, how do you solve this?
Since there's x squared on one side
Yeah.
and on the other, you subtract it?
You subtract it? Like what? So move all the terms to one side, you mean? Like subtract x on this side and put it over here like this? We could. We could. We get this now. We could. We could. And now what? Factor. Right. My favorite F word. Factor, please. That's like chapter 4 now. All that stuff from chapter 4 coming back to haunt you. Those of you who don't like factoring, I told you, you better learn how to factor. So help me out, somebody. Tell me two numbers that multiply to -6 and add to -1.
-3 and
-3 and
-2.
-2?
2.
+2, right? Because you want it to be -1. Good. And how do you solve this? Remember, you want to make one of them equal to 0, so either this equals 0, therefore x equals to
Cannot equal
3. Not cannot equal, x equal to, I'm solving now.
Oh.
X equals to -2. And just double check if they're NPVs. They're not, so we're good. Yay. Done. See how math builds on previous things? Those of you who didn't like factoring, you're going to have to learn it sooner or later. Okay. All right. Try number C. First of all, what's the NPV?
0.
0 again, yeah. They all seem to be 0 for the first row. Okay, they're not always 0, by the way. Okay, now what's the common denominator?
X.
X? 2x?
Oh.
1? What? First of all, what's the denominator for this thing here with the x left over?
1.
Right, that's just a 1. So don't forget that can be written as a fraction with a denominator of 1. So can someone suggest to me what the common denominator is? I need a 2 for sure. What else do I need? An x for sure. And I need a 1, but, you know, do I go 1 times 2? Well, no. I just write down that as, oops. What did I write it as? What happened to my notes? Anyways, write it as 2x. Okay? Okay, so there you go. There's your common denominator of 2x, because 1 times 2 is just 2. And now I would like you to do the same thing and see if you can figure out how to equate the numerators. Okay? Please try this on your own. Don't just watch me. Which factor am I missing from the first fraction there? X. Good, thank you. What am I missing from the next fraction? Nothing. Good, so just leave it. And the last one here, what am I missing?
X.
Just x?
Sorry, 2x.
Yeah, you're going from 1 to 2x. I need to multiply that by 2x. There you go. Okay, go ahead, please. Equate numerators and go ahead and solve. Okay, you try this, please. Okay, try on your own. Don't wait for me. So I will multiply things out here. That's 2 times x, or sorry, 2x times x is 2x squared. 3 times x is 3x. This equals to 2x minus 3, and this is also another 2x squared. Now, once again, for this one, notice you've got x squared, so you can just simplify them. They're both the same. And therefore, I think what I'll do now is I'll just subtract 2x on this side. So I get x equals to, hey, negative 3. Correct? Yeah?
Wait,
Good.
why?
Well, I just moved these 2 x's to the left side. Done. Okay, great. Shall we move on? Shall we move on?
Yes.
Okay. Let's move down. Okay. Some more interesting NPVs now. Someone help me out here. How do I find the non-permissible values? Well, remember I want the denominator to be not equal to 0. So I'm going to take the 5x minus 3, the first denominator on the left, and make it not equal to 0. And if you do this, can you solve? What do we have? 5x can't be equal to? Well, when you bring it to this side, it becomes a positive 3. And therefore now what's x not equal to? Over 5. So I want to solve for x, not 5x. Okay, so divide. So there's 1. Okay. What's the other one then, everybody?
1 over negative 1 over 5.
Right. Oh, not negative 1 over 5. I think it's just positive. I'll show you all the work. When I bring the negative 1 to the right-hand side, it becomes positive. Then I'll divide both sides by 5, so that's negative 1, or positive 1/5. Okay? Those are your non-permissible values. Great. Okay? Now, what's next? We want to solve these equations. Okay? Solve. What's the common denominator for this one? 5x? Just 5x? Well, it's that whole thing. Remember, you gotta look at these things as one entire thing. So really what I want you to understand is that the common denominator is just those two binomials multiplied together. 5x minus 3, 5x minus 1. Okay? So the common denominator is just those two things multiplied together. Now, once again, the same idea applies. Figure out what the numerator is going to be. What's the numerator here? We had a 3x minus 5, but I want to make it an equivalent, so what factor am I missing that I now must multiply by the numerator? 5x, say again, Sophia? Which one? 5x, I couldn't hear you. Which one? Minus 3 or minus 1? Minus 1, good. Okay, that's the one we're missing. And then on the right-hand side, which one am I missing? 5x minus 3, good. Okay. Sorry about this, it's getting too tight here. Okay. So once you've done that, you found the common denominators. My next step is always to equate the numerators. So just go ahead and equate the numerators. And in this case, unfortunately, you're going to have to do some multiplication. Okay, so 3x times 5x is 15x squared. 3x times 1 is negative 3x. 5 and negative 5 is negative 25x. Negative 5 and 1, positive 5. Okay. And then please do the same thing with the other side here. So go ahead and try that, please. 3x times 5x is 15x squared. 3x times 3 is negative 9x minus 5x. plus 3. Okay, so I've multiplied things out. I'd like you now to take some time to try to group terms and simplify, and let's see if you can get a nice, lovely answer for x. Okay? Yes, Kevin. Yes. Kevin, correct. You can just cross multiply. But why does cross multiply work? This is the reason why. Okay? So I just showed you why cross multiplication works. Kevin just said, hey, Mr. Lee, you just took the top fraction from the first one, multiplied it by the bottom fraction. You crossed this. Yes, I did. Very good. Okay? And on the right-hand side, I also crossed the other part. Yes, very good. That's right. Why does cross multiplication work? Cross multiplication really is just this. Okay? Cross multiplication is like a little trick. There's no mathematical reasoning behind it. This is the reason behind it. Okay? So go ahead, keep solving, please. Group terms together, solve. Let's see what you get for x. Okay. Well, you still need to expand it. But that's why. How about those 15x squareds? Goodbye, goodbye, right? And then negative 3 minus 25, I see there's negative 28x plus 5. And on this side, there's negative 14x plus 3. Okay, so back to now grade 9 algebra. Somebody help me out. What should I do next? Together. Together what? What should I put together? Negative 14x and put it to the other side? Sure. So I'll add 14x to both sides. What's negative 28 plus 14? That's just negative 14x. Okay. Still not too sure yet because I want to solve for x. What's next? The 3 on the other side? I don't know if I want to do that. I'm thinking I want to actually move the 5 to the other side because then I can separate them. So if I do this, what's 3 take away 5? That's negative 2. So negative 14x equals to negative 2. What's x equal to? How about negative 2 over negative 14 or 1 over 7? Good. Smiley face. Okay. There you go. Okay, ladies and gentlemen, like I said, this stuff, once again, review of last day, because ultimately the steps are almost the same. You're just extending last day stuff a little bit more to try to solve. Okay? And if you try E now, which I'll let you try on your own, can someone suggest to me what the denominators are going to be? The common denominator for E? X plus 3. Good. So I'm going to ask you please to rewrite every one of these fractions with the denominator of x plus 3. Okay, and try to solve from here. Okay? Go ahead and try that please on your own. Give you some time. Okay? You don't need. By the way, for E, I didn't do the NPV. Can someone tell me what the non-permissible value is? Negative 3. Good. X can't be equal to negative 3 coming from this denominator. Good. I look at the first fraction and I'm saying I'm missing a factor of x plus 3. I look at the middle fraction, I'm missing a factor of nothing, so I'll leave it as is. I look at the fraction on the right and I'm missing an x plus 3, so I multiply by x plus 3. Equating the numerators now, I'm going to just take a look and multiply this out. X squared plus 3x minus 12 equals to negative 2x minus 6. And then notice in this case I can't get rid of my x squared term, so I'm thinking I'm going to move all the terms now to one side. So if I were to now add 2x to both sides, and also over here add 6, look what you get. X squared plus 5x minus 6 equal to 0. Good. Okay? And once again, whenever you can't cancel out the square term, you have a linear term and a constant term, just shove everything to one side. Because now once you get to this step, what can you do to try to solve for x? Factor. Good. By the way, what happens if you can't factor?
Bottoms up.
Bottoms up? Well, that's part of factoring too, but what happens if you can't factor? What do? You give up? You don't give up. The negative b, right. Remember the song? You use the quadratic formula, right? Negative b plus or minus b squared minus 4ac over 2a. I'll get Andrea to sing that for you later on. So anyways, factor here, please, okay? Let's factor. So find two numbers, please, that multiply to negative 6 and add to 5.
What?
Yeah, what? Two numbers that multiply to negative 6 and those same two numbers add to 5. 6 and 1. Which one's negative? Negative 1. Excellent. X plus 6, x minus 1 equal to 0. And when you solve from here, by the way, yeah, I saw a lot of you use 3 and 2. Oops. This is just negative 6, and this just equals to 1. Great. Yay! Done. Whew. I think I'm just going to do F and maybe G and H, and I'll stop today. I won't do the word problems today. Sound good? All right. So we'll just do all the algebra today. We'll do the word problems next day. Okay, next one here. Help me out. What's the common denominator? By the way, this middle part here, I hope you think, that looks very familiar. It's a difference of squares. What I'm going to ask you to always do is see if you can factor first, and that's what I did last day too, right? Factor first. And if you factor this first, what do you get?
X minus 2x plus 2.
Yeah, so let's rewrite this as 2 over x plus 2. I'm going to add 8 over x plus 2, x minus 2 equal to 1. Okay, so I just wanted to factor into the binomials first. That makes such a huge difference because now when you look for your common denominator, it should be easier to spot. Can someone now tell me what the common denominator will be for this one?
X minus 2.
Yeah, thanks, Tanessia. X plus 2, x minus 2. Okay. All right. Okay. Ladies and gentlemen, let's see what you got. My numerator, 2. The factor I'm missing is? Minus 2. Good. I've got an 8 here. The factor I'm missing here is? Nothing. Good. Got a 1 over here. The factor I'm missing is? Both of them, right? X plus 2, x minus 2. Okay. Time to equate the numerators. So here we go. The fun begins. 2 times x is 2x. 2 times negative 2 is negative 4. Plus 8. And this part, difference of squares, I'll simplify it to x squared minus 4. Yes or no? Yes. Okay. Now, let's move all the terms to one side. Because I see that x squared is already positive on the right side, I like being positive, dealing with positive x squareds. So I'm going to move everything else from the left side over. So I'm going to subtract 2x, I'm going to add 4, I'm going to subtract 8. Okay, and let's see what you get. I believe you get 0 on the left side. X squared minus 2x, and I get, I think, minus 8. Agree or disagree? Okay. So, what's next? Yes, factor. Can someone help me factor x squared minus 2x minus 8? Minus 4 plus 2. And I saw a lot of you do this, which I was very happy. And then you boxed it, and I thought, whoa, 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 whoa. What do you mean you can't equal negative 2? What do you mean? Oh, yeah. Oh, snap. I forgot to find the NPVs. What are your NPVs for this question? X can't be equal to 2. X can't be equal to negative 2. This is why we find them now. Because look, the algebra here actually gives you one of your NPVs as your solution. But if I were to plug in x equals to negative 2, I get problems. The denominator equals 0. It can't happen. So you have to cross this out. There's a special name for a solution like this where the algebra makes sense, but when you plug it back in, it doesn't. It's called an extraneous root. Okay, so I don't know if you'll see this in your textbook, for those of you who actually open your textbook. Okay, but in any case, this is an extraneous root. So on your test or your worksheet, you should only quote me this answer. So and for this one, there's only one solution. Oh, now it gets nasty. Okay, ladies and gentlemen, we finished the first page. I like to try G and H with you, and then I think I'll stop, okay? So what I'm going to ask you to do now is let's do G and H, and before you try G and H, there's actually a mistake for H. My apologies for those of you who already started H. But for H, I think this first thing here should be x plus 2. So can you make that change? Thanks, Susan, for telling me about that. Hee hee hee. Okay, so x plus 2. Okay. Now, I'll help you start G. I see this ugly denominator here, x minus, or x squared minus 4x plus 3. What do you think you need to do with that, first of all?
-3 times -1.
Good, that's -3 and -1, good. So if you want, you can rewrite this as 2x over x minus 1 minus 4 over x minus 3 equals to 5x squared minus 7 all over x minus 3 x minus 1. And I think that helps you a lot because now I hope you can find the common denominator. Anyone have a suggestion for me?
X minus 3, x minus 1.
Yeah, just x minus 3, x minus 1. Okay. Go ahead now, please, and I'm going to let you try to solve this on your own. Same thing with H. And then once you're done that, I believe let's not worry about the word problems. You can start working on the homework assignment at the back or finish off that worksheet you didn't do. Next day you come back, we'll do the word problems with you then. Okay? A reminder, your test is in a week, I think. Next Monday. Coming up fast. So let's go. I'll quickly say that the factor I'm missing for this one is the x minus 3. This one I'm missing x minus 1. And this one over here I'm not missing anything. Equate your numerators. 2x squared minus 6x. Okay, ladies and gentlemen, this part's tricky right here. This minus sign applies to everything inside the bracket. So I'm going to put a bracket around there. So I get 4x minus 4. Okay? Because, once again, I'm saying subtract the entire fraction. So subtract the entire fraction. Okay, I will continue to simplify here now. 2x squared minus 6x. This just becomes now negative 4x. This becomes positive 4. And now I want to group all the terms on one side. I'm going to group everything on the right side because I'm going to subtract 2x on both sides. So that's 3x squared. I see now positive 10x. And what's this? Negative 7 minus 4 is minus 11. Good. Now, for this one, dear friends, I don't think you can actually factor this. I don't know two numbers that multiply to negative 11, or sorry, negative 33, right? And add to 10. So if you can't factor, what do you do?
Quadratic formula.
Yeah, use the quadratic formula. Andrea, you're on. X equals 2. Wait, I'm too fast. B squared minus 4AC. Yeah? All over 2A. Good. Out of tune, but good. Andrea is available to do birthday parties and other things too. Okay, so let's go ahead and solve this now. So negative b plus or minus b squared, that's 100, minus 4ac. Let's see what that is. 4 times 3 is 12. 12 times 11 is 132. That's 232, correct? Okay. All over 6. Now for this one, because it's an ugly number like this, I'm going to ask you to give me decimal solutions. So let's use your calculator now. Bring out your calculator. Let's see if we can find some decimal solutions to this question here. Okay, oops. So that will be negative 10 plus the square root of 232. I will press enter, then divide by 6. How about 0.87 as one solution? And then I'll do negative 10 minus the square root of 232. right? Then divide by 6. How about negative 4.2? 4.21 or 4.2? 4.21. Okay? So two different solutions here. Decimal answers. Okay? All right, ladies and gentlemen. I'm just going to give you the answer to H because I don't want to do this. You want me to do it? So you do it. Here's my answer. Is that right? Yeah? Okay. Ladies and gentlemen, you work on H at home, please. Okay, we'll stop here for today. We'll do all those word problems next class. But dear friends, you should be able to start the homework down here as well. So on the back page, the home learning on page 348, start working on these. You should be able to do at least like the first row up top. All right. Don't forget you've got that worksheet for those of you who didn't hand it in yet. I want that as well. You got lots of math to do this week.